Hello. So for today's video, it is the next topic is vector analysis. It is again in the order of the syllabus, which is provided on the website of CSIR-NET. So first question under the topic of vector analysis is from 2019 December. Question reads as: consider the set of polynomials xt is equals to a0 plus a1t plus an minus 1 t to the power n minus 1 in t of degree less than n, such that x of 0 is equals to 0 and x of 1 is equals to 1. So in this question we have to tell whether it constitutes a vector space or it does not. So for a vector space, we know that this is an important concept to know and to remember. For a vector space, it must be linearly independent. And by the fact of linearly independent, we know that the coefficients must be 0. All the coefficients must be equals to a2 is equals to so on an minus 1 equals to 0. So therefore from x of 0 is equals to 0, this is the condition which has to be satisfied for linear independency, and then it will constitute the vector space. If it doesn't satisfy this one, then it is not a vector space. Okay, so now first condition we will check, which is provided in the question given: x of 0 is equals to 0. Okay, so when we will put this one in the given equation, we will have x of 0 is equals to a0 plus 0 plus so on plus 0. Okay, so this must be equals to 0 since x of 0 is equals to 0. So a0 is equals to 0. For first condition, our linear independency is satisfied. Now for the second condition, x of 1 is equals to 1. So x of 1 will be a0 plus a1 plus a2 plus so on an minus 1 equals to 1. So a0 is equals to 0 from the first condition, so a1 plus a2 so on plus an minus 1 must be equals to 1. So this condition doesn't satisfy our required condition, which is this one. It doesn't satisfy this one. So finally it does not constitute, because from our given condition in the given question, both condition must be satisfied. Therefore this does not constitute a vector space. Option D will be correct. Option D. Our next question is from 2019 December only, same. We are given in the question the values of A and B for which the force F given as this is conservative R. So another concept which has to be remembered: curl of F equals to 0 is a required condition for the force to be conservative. Okay, now we will substitute for the following equation. We will have curl of F is equals to I j k, okay, del by del x, del by del y, del by del z. This will be axy plus z cube x square bxz square. Okay, so this will become, I will write it here, I del by del y of bxz square is 0, del by del z of x square is 0, minus j cap del by del x of bxz square bz square minus del by del z of axy plus z cube is 3z square. If I am going too fast, please slow it down by the option provided by the YouTube. Okay, I think I'm not doing fast. Okay, del by del x of x square is 2x, del by del y of axy plus z cube is ax, which is 0. This is 0. So comparing on the both sides of the this equation, we have j component is 0 on the other side of the RHS. So bz square minus 3z square is equals to 0. So bz square equals to 3z square, z square cancel, b is equals to 3. Another one, k component is also 0. So 2x is equals to ax, a is equals to 2. So a is equals to 2 and b equals to 3 is the correct answer. So option A is the correct answer. Option A is the correct answer. Okay, now we move on to another question, which is from 2018 June. Consider the three vectors v1, v2, v3 given as 2i plus 3k, I plus 2j plus 2k, and v3 is 5i plus j plus alpha k, where I, j, k are the standard unit vectors in a three-dimensional Euclidean space. These vectors will be linearly dependent if the value of alpha is. Now, another concept which has to be memorized. That's why I'm quoting it like this. So, if there are three vectors, suppose they are A, B, and C. So, for them to be linearly dependent and linearly independent, condition is as follows: A dot B cross C. This is a triple product. Okay, this is represented as A1, A2, A3, B1, B2, B3, C1, C2, C3. Here A is A1 I plus A2J plus A3K. Similarly, all others can be written like that. So if it is equals to, if this determinant or this triple product is equals to 0, then it is linearly dependent. Okay, if it is not equals to 0, then it is linearly independent. Okay, so this is the concept which has to be remembered. Okay, this has to be remembered for always. Like, okay, now we will put for our equation. Now v1 is provided as here 2i plus 3k, v2 is given as I plus 2j plus 2k, v3 equals to 5i plus j plus alpha k. Okay, so now we will substitute in the above condition, which I have already quoted in the box. So this will become v1 dot v2 cross v3. This will become 2 0 3 1 2 2 5 1 alpha. This must be equals to 0 if it is linearly independent. This condition, this is given in the equation. This is given in the question. Sorry. These vectors will be linearly dependent if the value of alpha is. Okay. So here we will solve this. 2 alpha minus 2 plus 3 1 minus 10 is equals to 0. So this will become 4 alpha minus 4 plus 3 into minus 9, which is 0. 4 alpha is equals to minus 4 minus 27 is equals to 0. 4 alpha is equals to 31 and alpha is equals to 31 by 4. So this is the required answer, which is the option 1. So option 1 is the correct answer. So here we have finished the part related to vector analysis. Only these much questions have been asked in last 10 years regarding vector analysis. There can be bit and scatters of in any other topic of vector related to vectors, since it is used in every other topics. Okay, so I'll be touching now another topic from the syllabus, that is about matrices only. So if more question has to be done, please post that question. I will do it. Thank you for today. Take care.